we're going to go ahead and share the floor with you, Alexey. Welcome, and we hope we have a good presentation for you. So whenever you're ready, you can start sharing your screen, and we can get going with the presentation.
Okay. Hello, everybody. So I think it's almost loaded already. Okay, here we go.
Okay, we can see your screen.
So it is being loaded. Let's wait a minute. And basically I will maybe, while it's loading,
yeah, you can introduce the...
Yeah, so this is the standard course project for the ROS2 basic course on Python. Honestly, like, I didn't know Python. I knew ROS a little bit, and the course is pretty awesome. Actually, I want to thank you guys to use this opportunity, because like it's one of the best online courses I have seen so far in general.
Yeah, thank you.
No, seriously, like, no joke. Anyway, this one contains of 3 parts. The wall following behavior is just a basic like node creation. Then there is a service called wall finder and the action ADOM recorder. So let me try to connect to robot. It's pretty slow today. So in the first part, the wall following behavior is that the robot need to measure the distance to the right and then keep it between 20 and 30 centimeters and move a little bit left, a little bit right, and if it hits the wall in front, then turn to the left. Straightforward algorithm. There was a one, like, initially I created it using timer and subscriber, as it was described in the course.
Mm-hmm.
But then, while I was learning further, I switched to callback functions. I actually I had even a ticket opened about that. I think you should be including callback functions and multi-thread executors in the basic course because I don't see the way how it can be done properly otherwise if you have a robot that subscribes to something and does something.
Correct.
Yeah. So I had to learn this portion myself. Then I found on the forum that it's actually it is an intermediate course, but this one was very helpful. So the way I did it is everywhere, in service, in action. It was most critical in service and action because it's very hard to write an algorithm if you are not in parallel receiving another value. And what I found is that if you call the spin function inside of callback function, then it works only once. The next time you call the node, it is in some state that is not it's just not working. So basically everywhere I use that callback functions, the executor, multi-threaded executor, and reentrant something.
Reentrant callback group, yes.
Yeah, so this
Alexey,
one.
Do I mind interrupting you?
Sure.
Just so we get a little clear idea before we look at the code, can we just see it, the main program, so then we can, when we're looking at the code, we kind of associate.
Yeah, absolutely. So let me move the robot somewhere where it is not going to find the
obstacles.
The obstacles in the middle, because something like this should be enough, I think. Then we'll start the bridge. Where is the bridge? The bridge is somewhere here. Here's the bridge.
So here you're using a ROS bridge because the robot runs under ROS 1. So, and your programs are ROS 2. So this is, for everyone that's listening, this bridge is what connects the robot with the ROS 2 programs.
It's pretty slow today.
Sometimes you have to like ask for the topics for the bridge to kind of get going. So maybe there it is.
No, it should be fine. Like, okay. So this is my main program. The node is called wall follower, and it's called the main program. It runs for three nodes.
All right, so we can see the
wall following, wall find, and yeah. So yeah, it already found. So basically, it already found the wall pretty quickly, and now just following it.
And now it's looking at his right and then turning depending
on. Right. I have logs here. The wall follower node is the one. So it turns a little bit left, a little bit right. Then when it faces the half a meter in front, it slows down, almost stops, and turns on quickly to the left. So also it measures the distance, and as you can see, like this is one is coming from odom recorder, the other one is received by the total distance received by action feedback.
Okay.
And it's also measuring the distance to, as you can see, to the initial point.
Nice.
Like I had to increase the distance to 10 centimeters because I was struggling to get, like the way I did it is it will stop, it should stop if it gets to the final, to the same point. Well, but it didn't because it was not accurate enough. So that's why.
So it didn't enter the threshold.
Yes. So with 5 centimeters, I was almost not able to achieve that.
That's great.
So 10 centimeters, it works in 50% of cases. 20 centimeters works always.
So then the issue for it to stop is
it didn't get to the initial point. So it saved the initial point somewhere here.
I see.
And like when it came again, it
wasn't not exactly there.
Yeah.
All right.
So that's where in the code I have like it's currently set as 5 centimeters. If I change it to like 10 centimeters, it will work better.
And so is there a way to sort of return your action result at this point, or is it just going to go on forever?
It will go on, like it will stop only when.
So it'll do another lap and then it'll try again.
Another lap, and it may be a fit now. I don't know. We may be lucky. So it depends. Like sometimes it's 3 laps, sometimes it's. So it was close, like 20 centimeters, 17, and that's it.
Okay, nice. Well, we can actually leave it running while you just look.
Let's
show us the code, and maybe the threshold will be hit. But yeah,
so let me talk through other things then. So this is the normal behavior. Yeah, I did it exactly the same. It was very detailed described. Less than 20 centimeters, turn a little bit left. More than 30 centimeters, a little bit right. Between those values, just straight. In front of, if there is in front for a wall, 50 centimeters, then it turns and slows down and turns. Yeah. So now about the wall finder, I actually did it same. It was very detailed in the description. I just took the portions of like how it was written in the notes.
Yes.
So it finds the distance to the nearest pole and so on. The only thing that I changed is it actually defines which, on the second step, it defines where to better to rotate. Depending on where it found the minimum value, it will rotate one way or the other way.
Mm-hmm.
This is the code for that. And basically everything else is just straightforward. So it rotates until it's exactly as it is shown here.
Okay. Pretty straightforward.
Yeah. What I found once when I was testing on real robot is that looks like because this service is subscribed to Laser, as well as the main one is also subscribed to Laser.
Oh, okay.
Well, because they both need it. And actually, the wall finder, the service, doesn't need to be subscribed the whole time. What I was trying to do myself, and I was not successful with that, by the way, I was trying to start the subscriber within the callback and then destroy it afterwards, so that it's not using resources. But it didn't work for me for some reason. Like, from the other side, I didn't solve that yet, but I want to understand, like, if it's possible at all or not, to, like, inside of the service call, to start to subscribe to something.
Right, I understand. So once you do the callback in the server to create the subscriber for that, and then to kill it, sort of.
Mm-hmm. Just not to waste the laser.
Right, right. I actually. So yes, you could actually just make it do the callback of the subscriber once you do the callback of the server, right?
So what I was doing is, this is in constructor now.
Okay.
I was putting this one inside. Well, first of all, it was a local variable, and I was putting this one inside here, but it didn't work. It didn't return any values. Also, I have re-entrant callback function. I didn't understand why, actually.
Right. Well, actually, I would only look at doing that to save resources in case you run into the problem, right? So if there's a connection, like a subscription open all the time, I don't think that's going to be so. Unless you're doing something with it really complicated, I think it's okay to just have it in the constructor like you have it there. Unless, of course, you start seeing that because it's listening to the scan, the server the whole time that it's running, you can also kill the node. You know, once you get a result, you can shut down that node.
I can kill the whole node.
Right? You can do like a ROS-B. I'm sorry, this is ROS2, like an RCL Pi shutdown or something. And then, so you'll only be able to call it once and then it gets called. So then you have to launch it again if you wanted to use it again. But that's another way you could do it. So,
it's a good idea.
Yeah, that's a good point. That's a good way to think about it, which definitely makes you understand this.
For some reason it didn't work. I didn't understand why it didn't work.
If you put it in the...
Yeah. If I put it inside the callback, the creation, the constructor.
Usually it's not a good idea to put a callback within a callback.
Well, it's not. It's a create subscription.
Oh, right.
It's not callback.
Yeah, but the subscription will call the callback every time, you know? So every time a new message comes in, you can't control that with the lighter because it's always going to be receiving. That callback's going to get executed. So a lot of weird things happen if you do that. You could do... That's why you could do it with the multi-threading, you know, that I wanted to ask you to just explain it a little bit more, why it prevented you from going forward, just so we have it a little more clear, and how were you able to get past it? So why did you need to do this multi-threading?
Well, because, for example, this is the logic of the service. There are different stages and of the code. Also, maybe I could write a timer and do something like the state machine, all these things. It's much easier to just write the code as it is, knowing that the values that I'm looking at, these ones, and like several values that I'm reading, it's just much easier to write the code.
Right, and you need those to change. You need those to.
Yeah, I need those to update. I was like, the way it is actually the first problem. Well, I was submitting the quiz in one of the, I think for services, the quiz for services. And when I saw the solution had just spin inside. So I tried that even before, but in this case, the node becomes like you cannot run this callback again. The node can somehow, if you call the spin function inside, so it's not a good solution actually. It works only once. While then I started digging internet and so on, finally found the solution somewhere, and then I found that it was already asked by some guy in the forum. So I didn't know about the forum. So I think that's just the right way of doing things.
Yes, definitely. Yeah, I just wanted to make sure. Yeah, and you said then this was not included in the course.
It was not, like not in basic. It is an intermediate course.
Yes, let me make a note of that because.
Yeah, like I actually like I proposed that, and there was another guy who agreed actually that they will get this included. But I think it's important. It's not that complicated, but I think there is no other, like just reading through the course, you will not get understanding how to do it the right way, because this is the right way.
Yes,
right?
yes, and in ROS 1, for example, you don't need multi-threading for an application like this. So yes, I agree with you. And
okay.
let me ask you one more doubt I have, and it's regarding this initial point. So I want to look at the action server and how you determine that initial point and the ending of it. So can you explain that?
Yeah, so this is the, okay, here I just have the listener, the callback for ODOM message, and basically this is how I save it. As soon as you start the callback, you save the first ODOM. This is the distance, and then like this is the while piece. One more thing that I should mention, because if you just keep it like this, it will immediately trigger. So I have another way to understand that it first left initial position. With a variable for that. And then if it already left initial position and the kind of returned, so the distance between last DOM and first is more than, so then like it continues recording. The stop of robot, it is happening in the main function once the action is completed somewhere here. Yes.
All right, I understand. So, so I have a couple comments on that. That's great that you went a step further, because the sort of quick and dirty way of doing it would be something like just measure the distance and stop it after you see it. You print out the distance the first time, and then you see it do a whole loop, and then you check how much distance that was, and then just make the server stop here. But you did something that's pretty good, but there's a problem there that I see, and it's that the odometry of a robot will always drift, right? So it will accumulate error as it goes on and on and on and on, right? And this is just the nature of like encoders of a motor that run the wheels there. So that's why, for example, in navigation algorithms and like that, you don't rely exclusively in the odometry, because it might tell you, oh, I'm here based in odometry, when in reality I'm after an hour. This is a good example. It's been going on and on and on. It's going to be like really accumulated errors, so it's going to be less and less probable that it arrives to the same location, right? So that's why I think it's not arriving, because once you add the whole thing, you're not going to be exactly at the same point every time, so you have to do a bigger and bigger threshold. So Another way of trying to do this, although this isn't part of the basics, but are you familiar with frames, with frame publishing in ROS2? Okay,
well, frames, you mean TF?
Yeah, TFs, yes.
Well, let's say I know what it is from your EF course, but not more than that.
Right. So yeah, I recommend you take a look at that because it's also very useful for things like this, that you don't need it to be fully precise, but you need something like an approximation. For example, you can publish a frame from the link to like a new dynamic frame that when it starts, and then you just track the transform between that frame where it starts and the robot.
Well, but
that could be another check.
It's the same thing, isn't it? Because when it calculates, it will, well, okay.
But maybe the way you do the threshold is accomplished better because here is at the 20 centimeter and we see that it didn't really reach it. So I'm just, or you could use the laser, to look for a landmark or things like that, you could use to go around like this odometry drifting that I'm pretty sure it's like ubiquitous in all like differential drive robots that are like this. So, but what I wanted to say is that it's a good way, regardless, with the tools you have, to make it stop after one lap. But yeah, that's
thanks.
Mostly the points I see from your robot. Other than that, I'm from your project. Sorry. Other than that, it looks really, really good. So congratulations. Do you mind stopping sharing your screen so we can just see our faces here? Great. So again, congratulations, Alexey. It was a really, really good point. I really like that you went into this extra step of that makes you find out things about like the robot, like the odometry, and it's great that you were able to figure out that multi-threading, which is essential for a service like this, that where you need to do that. So I made a note of that so we can include that in the course in a simple way, so it doesn't take away from the learning. So. But anyways, if anyone else is watching, this is what you can do here for our course for ROS2 Basics. We have many other courses that offer a certificate, so you can do what Alexey did here and check us out. So thank you, Alexey, for a great project, and hope to see you next time.
Great. Thank you.
All right, guys. See you soon. Bye-bye. All right.